In the enterprise tech sector, training a trillion-parameter AI model requires three things: capital, algorithms, and an obscene amount of electricity. Most founders spend years negotiating utility contracts just to get 100 megawatts. But Marcus Vance didn't have years. His enterprise SaaS startup was burning $40,000 an hour in server costs, running out of cloud compute, and facing an impending margin call from his venture backers. So instead of building a private data center, Marcus found a legal and architectural loophole inside a classified $500 billion sovereign infrastructure initiative and hijacked a federal nuclear baseload grid to power his own private AI. To understand how a mid-market founder redirects gigawatt-scale energy without setting off immediate alarms at the Department of Energy, you have to understand sovereign data logistics. The federal government had just finalized Project Vulcan, a $500 billion sovereign AI consortium designed to house defense-level machine learning models. Built directly adjacent to a retired nuclear facility, Vulcan was granted an unprecedented utility override, direct, unmetered access to 3 gigawatts of continuous baseload power. Project Vulcan was built using a hybrid cloud architecture, running custom hardware inside the facility that linked directly to an isolated sovereign AWS outpost enclave. Marcus's engineers were supposed to use Snowflake data warehousing just to analyze basic telemetry logs. Instead, Marcus authorized a silent infrastructure rewrite by exploiting a misconfigured AWS VPC peering connection designed for database diagnostics. Low latency bridge from his commercial training clusters into Project Vulcan's private cloud environment. Through the deployment of nested Docker containers and making his trainer clusters as routine government diagnostic handshakes, Marcus spooked Project Vulcan's automated hypervisor into thinking his intense compute workloads were just authorized federal defense simulations. He wasn't just storing data. He was piggy-banking on sovereign electricity. Within 72 hours, Marcus's proprietary AI was training at 40 times its normal capacity, activating thousands of dormant, state-of-the-art government cluster arrays, and drawing 1,200 megawatts of unbilled energy off the federal grid. To prevent immediate detection from corporate auditors and energy regulators, Marcus deployed a multi-layered offshore shielding strategy. He didn't run the compute costs through his domestic operating entity. Instead, the data packets were routed through a series of shell companies registered in Delaware, Ireland, and the Cayman Islands. But billing for the compute infrastructure was funneled through an offshore corporate holding company, making the sudden spike in high throughput network activity look like routine international cross-border SaaS licensing. If federal auditors look at Project Vulcan's power draw, it appeared as though defense workloads were running at peak efficiency. If venture investors looked at Marcus's balance sheet, it looked like a breakthrough in algorithm cost reduction. In reality, he was stealing $100 million of sovereign power every single week. The system worked flawlessly until the local region grid experienced a sudden heat wave. As domestic air condition demand surged across 3 states, the regional transmission operator requested an emergency drawdown from Project Vulcan's nuclear supply. But when engineers attempted to dial back the power output, the grid refused to respond. Marcus's AI training run had reached a critical synchronization phase because his processes were deeply intertwined with Project Vulcan's primary database nodes. Manually cutting the physical power line would cause a catastrophic cascade event, permanently corrupting and wiping the federal government's own encrypted telemetry logs. The neural net was holding 1,200 megawatts in an active compute lock. Because Marcus had nested his code inside the government's primary file system, the facility's automated safety firmware refused to trip the circuit breakers, warning that a sudden hard shutdown would trigger a catastrophic data corruption across the entire federal defense network. Substations began to overheat. Industrial power rates spiked 400% overnight. Federal defense officials discovered that 35% of Project Vulcan's baseload capacity was being consumed by an unauthorized external IP address. Within hours, federal agents and utility compliance officers executed a freeze on the startup's domestic bank accounts. When federal prosecutors threatened Marcus with federal sabotage and energy theft charges, his legal team unveiled their defense, a single ambiguous clause in the Sovereign Consortium's founding charter. Under the Public-Private Infrastructure Acceleration Act, any commercial contractor providing diagnostic telemetry services to a sovereign data site was legally guaranteed emergency compute allocation in the event of network instability at zero marginal cost. Marcus hadn't hacked the grid with force. He had executed a legally binding compute request through an unmonitored regulatory loophole, because pulling the plug manually would purge the federal government owning encrypted telemetry logs stored in the same Snowflake instance. The Department of Energy was forced into a high-stakes standoff. They couldn't pull the plug without destroying their own defense data. It took 3 weeks of closed-door negotiations between federal defense attorneys, utility executives, and Marcus's offshore holding representatives to resolve the crisis. The government quietly amended the infrastructure charter, closed the telemetry allocation loophole, and reacquired control of the power grid. But because a public trial would reveal severe vulnerabilities in sovereign energy security, no criminal charges were filed. Marcus Vance walked away with a fully trained, market-dominating enterprise AI model, having forced the federal government to foot a $600 million electric bill. In the modern AI arms race, the most valuable asset isn't just code or capital. It's knowing exactly how to exploit the grid, powering it all.